All right, let's talk about one of the hottest jobs in tech right now, the AI engineer. The demand is absolutely exploding, but honestly, the path to becoming one can feel a little murky. So today, we're going to lay out a clear step-by-step roadmap, from the fundamental mindset all the way to building a portfolio that actually gets you noticed. Let's dive in.
First things first, you've probably seen the term AI engineer everywhere. But what does it really mean? You know, it gets tangled up with machine learning engineer, sometimes even data scientist. But this is a newer, and I think, a very distinct role. Getting this definition right is super important, because really, it's going to shape your entire learning journey.
Okay, so here's our game plan. We're going to start with the mindset, which is a huge shift. Then we'll cover the non-negotiable engineering foundation you gotta have. After that, we'll get into the fun stuff, the core AI patterns, like RAG. From there, we'll level up to autonomous agents, talk about what it actually takes to ship AI in the real world, and then wrap up with how to prove you can do it all.
Let's kick things off with what I think is the most important piece of the puzzle, the mindset. And look, this isn't just about learning new tools. It's a completely different way of thinking about how you solve problems. It's all about building products, right now, in a world where these incredibly powerful AI models already exist for us to use.
So here's the bottom line. An AI engineer is a builder, a shipper. Your job is not to spend years creating a giant foundation model from scratch. Nope. Your job is to take these amazing pre-trained models, think GPT, Claude, Llama, and use them like a super-powered building block to create real-world applications that people can actually use. We're talking chatbots, search systems, automation tools. You get the idea.
And this is where we see a really critical distinction from the more traditional machine learning engineer. For a long time, ML engineering was very model-first. You'd spend ages gathering data, training a model, tweaking it, and only when the offline accuracy metrics looked perfect would you even think about shipping it. Well, AI engineering flips that on its head. It is product first. You grab an existing model, you build something useful, you get it out the door fast, and then you iterate on it in the real world.
And that product-first mentality leads us right here. Because if your job is to build and ship products, then your foundation has to be rock-solid software engineering. It is so tempting to just jump into the cool, flashy AI stuff, but trust me, skipping this step is probably the single biggest mistake you can make.
This quote just nails it, doesn't it? At the end of the day, most of your work as an AI engineer is, well, software engineering. You're building APIs, you're writing tests, you're architecting systems. The AI model is a crucial component, for sure, but it's just one piece of a much bigger puzzle. If your software skills are weak, the whole thing falls apart.
So, what does this foundation actually look like? Well, it means you have to be solid with Python. The entire AI world lives there. It means knowing how to build a backend server with a framework like FastAPI or Flask. You've got to understand how APIs work, use Git like it's second nature, package your apps with Docker, and write good tests with something like PyTest to make sure your code doesn't break. These are your essential tools.
Now, let's talk about math. And don't worry, you don't need a PhD, but you can't just ignore it. The goal here is all about practical understanding. You need just enough linear algebra to get that everything in AI is basically just a big list of numbers called a vector. You need some probability and stats to know if your model is actually any good, and you need the basics of calculus to understand how these models learn. It's not about proving theorems, it's about building an intuition for how these things work under the hood.
Okay, with that solid engineering foundation in place, now we get to the really fun stuff, the core mechanics of almost every modern AI app you see today, and the #1 most in-demand pattern out there is called Retrieval Augmented Generation. You'll just hear it called RAG.
So what the heck is RAG? Think about it. A model like GPT was trained on the general internet. It knows about Shakespeare and quantum physics, but it knows nothing about your company's internal wiki or your personal meeting notes. RAG is the technique, it's the bridge, that connects that powerful general model to your specific private data. This is what makes AI genuinely useful for a specific business or person.
Let's just walk through how it works, step by step. First, you take all your documents, your PDFs, your Word docs, and you break them into smaller chunks. Each chunk gets turned into a long list of numbers, an embedding that captures its meaning. You store all these embeddings in a special database. Then, when a user asks a question, you search that database for the most relevant chunks of text. You stuff those chunks into the prompt right alongside the user's question, and then the LLM generates an answer using that fresh, specific context. Simple as that.
And the real engine powering this whole thing is the vector database. This is what's so cool. A normal database searches for keywords. A vector database searches for meaning. It finds text that is conceptually similar to your question, even if the words are totally different. So you could search for reasons the stock market went down, and it could pull up a document that talks about key drivers of economic recession, even with no overlapping keywords. This is a search for concepts, not just words. And that is a genuine superpower for building smart apps.
Okay, so RAG is all about giving models knowledge. The next big step up is giving them the ability to act. And this brings us into the really exciting world of autonomous systems, or what we call AI agents.
So, what makes something an AI agent? Well, at its core is still an LLM, but it's supercharged with a few key things. It's given tools it can use, like calling an API to get the weather or booking something on your calendar. It has a memory to keep track of what it's done, and it uses the LLM's reasoning to plan a sequence of actions to achieve a goal you give it. This is what gives the system agency, the power to act on its own.
This visual here does a great job of showing the whole spectrum. Down at the bottom, you've got your basic chatbots and RAG systems. They're reactive. They just answer you. But as you move up the ladder, you get into LLM workflows. This is where the AI starts doing things with tools. Maybe it accesses your calendar to find a free slot. And then at the very top, you have these crazy multi-agent systems. Think of it like a team of AIs. One's a research specialist, one's a code writing specialist, and they work together, passing tasks back and forth to solve a really complex problem. That's a huge leap.
You know, building a cool demo on your laptop is one thing. But building a reliable, secure, and cost-effective AI application that thousands of people can depend on, that is a whole other ballgame. This is where we talk about going to production.
And this is where your software engineering skills really shine. You have to know how to deploy your app on a cloud platform. You absolutely have to think about security and who gets to see what data. You have to build systems that don't cost a fortune to run, because LLM API calls can add up incredibly fast. And, of course, you need really good monitoring, logging, and error handling to make sure the thing actually stays online and works.
So we've gone through the mindset, the foundation, and the core AI skills. How do you actually prove to someone that you've got what it takes? Simple. You build stuff. Your portfolio is, without a doubt, your single most valuable asset. And please, don't just build another simple chat with your PDF app from a tutorial. Go deeper. Build a RAG system, but add real security to it, like role-based access control. Or build a team of AI agents that actually work together to automate a real-world coding task. Or create a research assistant that can read 10 academic papers and give you a synthesized summary. These are the kinds of projects that really stand out.
And finally, remember this. Building the thing is only half the job. You have to be able to explain what you built and, more importantly, why it matters. This means writing clean documentation. It means drawing up architecture diagrams. It means recording a demo that sells your idea. The best engineers are not just great coders, they're great communicators.
And that brings us to the end of our roadmap. We've laid out the whole path, from that initial product-first mindset all the way to a production-ready portfolio. The steps are clear, the tools are out there, and the opportunity is absolutely massive. So really, there's only one question left. You have the roadmap. What are you going to build first?